All right, so it says which function is odd? Now, remember the odd functions, they have two properties, right? So one is that if I take the negative x value, I'll get the corresponding negative y value, right? Remember f of x means y. So an example of this would be is if I have negative 3 comma 2, then when I do the opposite of negative 3, I should get, in other words, positive 3 should yield negative 2. That's an odd function. That only occurs on odd functions. The other thing is that it is reflected about the origin, which is like a 180-degree rotation about the origin. I don't know why they don't say well, anyways, let's write this down one thing at a time. Reflected about the origin. So I could tell you right off the bat that this is odd. I'm pretty sure A is odd. And I'll explain why in just a second. Because if I take, when we say reflected about the origin, it's like a 180-degree rotation. But it has to go through the origin is the interesting thing. So there's two qualifiers, right? So this passes through the origin. And if I take this portion of the graph and I rotate it 180 degrees, I will end up right. It'll look right. It'll make this part of the graph. Okay. So it's definitely A. And that's it. Now I could double check this by saying, all right, well, I don't know what this value is. Well, I do actually. But let's assume it's like -5. So -5 yields approximately 2. Now there's a decimal. It's not exactly -5 and 2. But if I come over here to about +5, guess what? It's about -2. So there's that. So it qualifies both ways with this right here and then the rotation about the origin because it goes through the origin. Now this one is not odd because it doesn't go through the origin. I could find a point, flip it, rotate it 180 degrees, but it has to go through the origin. This one is even, but again, it doesn't go through the origin. This one doesn't go through the origin. So the only one that qualifies is A.